Good morning and welcome to today's Mr. Boskin Does Some Math. Today we are working with Illustrative Math Grade 8, Unit 7, Lesson 14. So our warm-up problem today is some true or false questions. Is each question true or false, and explain your reasoning? 4 times 10 to the 5 times 4 times 10 to the 4 equals 4 times 10 to the 20. This one, if we were to rearrange the pieces using the commutative property of multiplication, we would have 4 times 4 times 10 to the 5 times 10 to the 4. 4 times 4 is 8. 10 to the 5th times 10 to the 4th, when we're multiplying like bases, we add the exponents, is 10 to the power of 9. Does that match? No. This one is false. Our next one, 7 times 10 to the power of 6 over 2 times 10 to the 4. Remember, a fraction bar means division. 7 divided by 2. 7 divided by 2, that matches. When we are dividing, we subtract the exponent, so it will be 10 to the 6 subtract 4. That also matches. This one is true. Number 3, 8.4 times 10 to the power of 3 times 2. If we were to rearrange so the individual numbers are together, we would wind up with 8.4 times 2. However, we would not have to do anything to the exponent here. That would not have to be multiplied. It would be 8.4 times 2, like they have it, times 10 to the power of 3, because we're not doing anything to that exponent. Question number 2 involves looking at this table. Use the table to answer questions about different creatures on the planet. Be prepared to explain your reasoning. So, looking at this table, our first column is creatures: humans, cows, sheep, chickens, ants, blue whales, Antarctic krill, zooplankton, bacteria. Then the next column is the number. How many of those creatures exist on the planet? And then our third column is the mass of one individual. How much does each one weigh? And that is measured in kilograms. These are all done in proper scientific notation, 1 digit in front of the decimal place. Which creature is least numerous? The least numerous creature here means first we're going to have to look at all of these exponents. Least numerous means the smallest number, the fewest of them. These are all positive exponents, which means they're all making the number bigger. So we want to look for the smallest number. The smallest number exponent looks to be blue whales. So the creature on here that there are the fewest of is blue whales. Estimate how many times more ants there are. So how many times more ants are there than blue whales? That will be a division problem. 5 times 10 to the power of 16 divided by 4.7 times 10 to the power of 3. Dividing this, we can start out just by dividing the numbers. 5 divided by 4.7 times 10 to the power of, when we are dividing like bases, we subtract the exponents. 16 subtract 3 is 13. So 5 over 4.7 times 10 to the power of 13. 5 divided by 4.7 is 1.06. So 1.06 times 10 to the power of 13. Ooh, that didn't quite fit. 1.06 times 10 to the power of 13. So the least numerous creature is blue whales, and there are 1.06 times 10 to the power of 13 more ants than there are blue whales. Our next question, which creature is the least massive? Estimate how many times more massive a human is. So the least massive, the smallest creature, seems to be a bacteria. So that's our least massive. How many times more massive is a human? Human So now we have a division problem again. How many times more massive a human is? We will have to do 1 times 10 to the power of negative 12. 12 divided by the mass of a human, which is 6.2 times 10 to the power of 1. Divide the numbers. 1 divided by 6.2 is 0.161 times 10 to the power of, now we have to subtract the exponents. Negative 12 subtract 1 is negative 13. Now, does that answer make sense? How many times more massive is a human? Negative exponent means 0.00013 zeros 161. I don't really think a human is 0.1 times bigger than a bacteria, which means we did our division problem upside down. So let me erase that and we'll flip it upside down. 6.2 times 10 to the power of 1 divided by 1 times 10 to the power of negative 12. 6.2 divided by 1, that's a much easier division problem. 6.2, anything divided by 1 is itself, times 10 to the power of subtract the exponents. 1 subtract negative 12 is 1 plus 12. 1 plus 12 is 13. That answer makes a lot more sense. So that's a nice little look into the thought process you have to do when you make a mistake. Does my answer make sense? Well, our first answer didn't make sense. Now, we can tell that a human is many, many, many times more massive than bacteria. Our next question will require a few more steps. Which is more massive, the total mass of all the humans or the total mass of all the ants? So we need to find out the mass of all of the humans, and we need to find out the mass of all of the ants. To find out the total mass, you take the number of items times how much each one weighs, the mass of each one. So we are doing humans and ants. So the mass of all humans will be 7.5 times 10 to the power of 9 times 6.2 times 10 to the power of 1. Label H for humans. Ants will be 5 times 10 to the power of 16 times 3 times 10 to the power of negative 6. Now we just need to multiply. 7.5 times 6.2 is 46.5 times 10 to the power of, when we're multiplying, we add the exponents. 9 plus 1 is 10. For ants, we have 5 times 3, which is 15, times 10 to the power of, again, add the exponents. 16 plus negative 6 is 16 subtract 6, which is 10. So this came out kind of interesting. They are surprisingly fairly close to each other. These have the same exponent now. However, they are not both currently in proper scientific notation. So, humans, the mass of all humans, we need to move this decimal point 1 spot, is 4.65 times 10 to the power of, it was 10, but we moved it 1 more spot, 11. Ants, 15, but we want 1 digit in front of the decimal place, so 1.5 times 10 to the power of, we moved it, it was 10, we're going to make this one 11 as well. So, which is more massive? All the humans on the planet or all of the ants on the planet? Well, it looks to me like humans are more. So all the humans on the planet weigh more than all of the ants on the planet. How many times more massive is it? Oh, we're back to a division problem. 4.65 times 10 to the power of 11 divided by 1.5 5 times 10 to the power of 11. Now, the first thing I notice here is we have something that cancels out. 10 to the power of 11, 10 to the power of 11, they're being multiplied. Those just cancel out. Anything divided by itself is 1. Or we could think about it when we're dividing like bases, we subtract the exponents. 11 subtract 11 is 0. 10 to the power of 0 is 1. So those cancel out, and we're left with just 4.65 divided by 1.5, which is 3.1. There are, or the mass of all the humans on the planet is 3.1 times greater than the mass of all of the ants on the planet. Okay, our next problem is very similar. Which is more massive, the total mass of all the krill or the total mass of all the blue whales? So we have blue whales and we have krill. Erase where I underlined that poorly so we can still read the number. So again, we are going to have to multiply these. Going to do this one a little quicker in one step. 4.7 times 1.9 is 8.93 times 10 to the power of multiplying, so we add the exponents. 3 plus 5 is 8. 8.93 times 10 to the power of 8 is the mass of all the blue whales on the planet. Krill, 7.8 times 4.86 is 37.9 times 10 to the power of 14 plus negative 4. 14 subtract 4 is 10. Now, this one is not actually in proper scientific notation. Let's move that decimal place over. 3.79 times 10 to the power of, we may move the number over one spot, to the power of 11. So now we know the mass of all the blue whales on the planet and all the mass of the krill. Which is more massive? This one surprised me a little bit. The mass of all of the krill, tiny little krill, is actually more than the mass of all the blue whales, big giant blue whales. Now we have to figure out how many times more massive it is. So dividing again, we want to divide the larger number by the smaller number. 3.79 times 10 to the power of 11 divided by 8.93 times 10 to the power of 8. First we divide these. 3.79 divided by 8.93 is 0.424 times 10 to the power of, we're dividing, so we subtract the exponents. 11 subtract 8 is 3. Now our number is not currently in proper scientific notation. We need one digit in front of the decimal point. So that should be 4.24 times 10 to the power of, well, we moved it backwards one spot, so we want to subtract 1 from that. Power of 2. 4.24 times 10 to the power of 2. So there are 4.24 times 10 to the power of 2, which you could also think of as just 424 times more mass of krill than the mass of blue whales. Okay, our next questions are about professions in the United States. The video's getting kind of long, so I'm going to try and work through these quickly. Answer the following questions about professions in the United States. How many times more nurses than there are doctors? Number of nurses, number of doctors. How many times more means we are dividing. 3.45 times 10 to the power of 6 divided by 6.9 times 10 to the power of 5, which will be 3.45 over 6.9 times 10 to the power of subtracting 1. I'll leave the division of that up to you. Next question, estimate how much money all doctors make put together, which is just multiplying the number of doctors by their typical salary. 6.9 times 1.87. 6.9 times 1.87. You can do that multiplication yourself. Times, add the exponents. 5 plus 5 is 10. 10 to the power of 10. So the salary of all the doctors combined is 6.9 times 1.87, which is going to be 13-ish, times 10 to the power of 10. Okay, the next question we have is how much money all police officers make put together. Police officers, another multiplication, 7.8 times 5.7. You can do that multiplication yourself. 10 to the 5 times 10 to the 4. 5 plus 4 is 9 times 10 to the power of 9. So that is the total salary of all police officers put together. Now, our last question is, who makes more money? All enlisted military put together, or all military officers put together? So, we have military enlisted and military officer. We want to figure out which group makes more money as a whole. So again, multiply these through. 1.16 times 4.38 is 5.08 times 10 to the power of, add the exponents, 6 plus 4 is 10. Now for officers, 2.5 times 1, that's pretty easy multiplication. 2.5 times 10 to the power of, add the exponents, 5 plus 5 is 10. It asked us also how many times more. Well, both of those have a power of 10. They're both one digit in front of the decimal place, proper scientific notation. So enlisted make more money than officers as a whole even though the officers make more money as an individual, but there are many more enlisted than officers. So now we want to find out how many times more, which means we just need to divide these. 10 to the power of 10 divided by 10 to the power of 10, that will just cancel out. 5.08 divided by 2.5 is right around 2, because 5 is double 2.5. So that is approximately 2 times more that the enlisted men make than the officers as a whole. This has been another episode of Mr. Boskin Helps You With Your Math. Thank you for tuning in.